So this is a quick aside or a brief note, just clarifying some definitions. So in case you haven't heard of divisibility, certain symbols, what it means to be prime or composite, that's what this video is covering. So the first bit of notation that I want to introduce here is the following. So this little vertical bar right here, we say M divides N. So the way that you read this symbol is M divides N. So we say M divides N if there exists some integer such that we can write N as M times T. So that's what we mean when we say this symbol right here. So for example, we could have three divides 6. And 3 divides 6, we have to find some other integer such that we could write 6 as 3 times something else. Well, that's pretty easy. That's a 2. So in this case, 3 divides 6. If you put a slash through it, that means does not divide. So here, 3 does not divide 8. Because we can't write 8 as 3 times some other integer. So that's what it means to divide or not divide. That's what I mean by those symbols. And using this allows us to define what it means for a number to be prime or composite. We say a number is prime if for every natural number, this following implication is true. If that number is not 1, and if that number is not n, then it does not divide n. That means n is prime. So this might be a complicated notation to be able to express that concept, but put simply in words, this means that a number is prime if its only proper divisors are 1 and itself. That's what this thing here is saying. The only proper divisors, the only things that can divide it, are 1 and itself. That's what it means to be prime. And if a number is not prime, then we say it's composite. So for a couple examples here, we know that, for example, let's see here, 7 is prime. And it's pretty easy to check that the only natural numbers that can divide it are 1 and itself. And 12 is composite. And the reason why it's composite is because there are other divisors besides 1 and itself. For example, 3 divides 12, and 4 divides 12, and 6 divides 12, etc. So one important thing to note about composite numbers is they have a really nice property. And that particular property is the following. If you have a composite number, so if m is a composite number, then you can always find numbers a and b, which are natural numbers, that are greater than 1, such that when you multiply them together, you get that composite number. So, for example, 12 over here was composite, and indeed we can see that we can write 12 as 3 times 4. So we've been able to write this composite number as 2 other integers that are greater than 1. And it's not too difficult to be able to prove this statement right here, because we know that if a number is composite, it has some other proper divisor. And if it has some other proper divisor, that could be your a, and then after you do the division, whatever you get left over with, that could be your b. So composite numbers have this nice property here.